All right, well, hello everyone. Good afternoon, and thanks for joining the October edition of the West Watch. This is Dan McAvoy in Reno, Nevada at the Desert Research Institute and Western Regional Climate Center. So I wanted to just give a very quick overview of what the West Watch is. Some of you may be new and some of you may be returning viewers. So this is a monthly webinar series, and it's primarily NOAA staff and partners. The intent was to share information about climate observations and anomalies and how it's impacting not just the ecosystem, but also human societies. And so there are two formats currently for the West Watch. The format you're going to see today is general climate and oceanic overviews. So from myself, from the Western Regional Climate Center, and then from our ocean observing system partners along the West Coast. And then the other format is more of a topic specific webinar. And so that will happen next month. And for example, last month we had a webinar on marine heat waves. And so a few housekeeping items before we get started. We do have one quick poll question that should pop up here in just a minute. And this is going to ask you, have you attended the West Watch previously? We'd like to get a sense of how many new viewers we have and how many returning we have. So if you'll just take a few seconds to answer that poll that's on the screen. And we could move on to the result now. Which is showing that we have about 25% of folks, this is their first time viewing. So thank you for joining and thanks for those returning. So on to the other housekeeping items. We'll have several speakers today, about 10 to 15 minutes per speaker. There is a place to enter questions into a questions box on the right-hand side of the screen, and so you can do that. And we typically do have a little time for Q&A after each speaker, and then again, hopefully at the end for a little bit of discussion. We'll try to get to as many questions as we can. These are being recorded, and shortly, within a few days, typically after the briefing, they will be posted, and you will be able to re-watch these or share these recordings. And you'll also receive a post-webinar survey, and we would really like some feedback if you can spare a little bit of time for that. And so on to today's lineup of speakers. So I'll be starting things off with the regional climate briefing and ENSO outlook. And then we'll have some updates from our ocean observing system partners. We'll start from the Northwest with Jan Newton, move down the coast to central and northern California with Henry Roll, and then move to Southern California with Clarissa Anderson and Jim Behrens. And so I'm going to jump right in here since we have a lot of content and get started with the climate update and outlook. And so I'd like to first wish everyone a happy new water year. Our water year begins on October 1st and runs through September 30th of each year. And so I just wanted to start with a summary slide with precipitation and temperature rankings from the 2022-2023 water year. These are graphics from the Westwide Drought Tracker. And so on the left, we have precipitation rankings, and these are based on PRISM data going back to 1895. And so anything in the greens are above normal precipitation rankings, and anything is brown is below normal precipitation rankings. And what we see is that most of the West is in the green shadings there, which is a good thing after several years of drought for some places. This was a drought-busting year for California into the Great Basin and parts of the Colorado River Basin. However, there were still some dry areas, particularly in parts of the Pacific Northwest, and then again in the southwest states of Arizona, New Mexico, and southern Colorado. And then on the right, we have the temperature rankings, with the blues being colder than average and the reds being warmer. And I think this is something we haven't seen in a while, is that there's more blue on this map than there is red. And so we actually had a cool water year for a lot of places, well below normal in some cases. But also those warmer colors sort of match up with the drier colors in Pacific Northwest and parts of the Southwest. And I did want to highlight there were some record wet and record cold locations this year. I've highlighted a few of those on the grids. And if you look at weather station observations, they do confirm that we did see some of these records, which for the cold is even more impressive. And if we move on now just to some of the more recent anomalies from the last 30 days. And so this is data from September 13th through October 12th. On the left, we have the precipitation, a percent of average. And then on the right, we have the temperature anomalies. And these are maps from Climate Engine. And so we see a pattern of mostly wetter than normal conditions in the Pacific Northwest and drier than normal conditions in the Southwest. And so we have seen a return to colder Pacific winter-like storms starting to return to the Pacific Northwest. There have been a few atmospheric rivers, and so this was welcome after kind of a long, warm, dry stretch for that area. And then on the right, there's still been some relatively cool anomalies over the last 30 days in the Great Basin in California and parts of the Southwest, and then some other areas that are above normal. And some of the warmer areas in the west are eastern Montana, northeast Wyoming, and southeast New Mexico. I did want to take a little time and talk about the southwest monsoon. And so this is a seasonal pattern. And the official way the monsoon is defined is precipitation from June 15th through September 30th for each year. And so I want to summarize the monsoon from this year, which was one of the drier ones that we've had in quite some time. So there are a couple of maps or graphics here on the left. These are both from University of Arizona monsoon tracker. And so the inset map is showing the southwest region that they define just as Arizona and New Mexico. And you see most of that map is brown, indicating below average precipitation for nearly the entire monsoon region. But the larger graph, the time series graph, is showing the percent of that area that is in these various categories of below average, near average, above average, and much above average precipitation. You see, as we go through time, it doesn't change through much, and throughout the whole monsoon season, most of that graphic is brown, indicating that most of the region was less than 75% of average precipitation. There was a bit of an uptick in August into early September, but still, there's very little green and blue shading, indicating very little areas of above average or much above average precipitation. Phoenix, Arizona had its driest monsoon season on record with only 0.15 inches. It was a little bit spotty. Tucson was below average, but just by a bit, and still had almost 5 inches of precipitation. And Albuquerque was also quite dry, the 10th driest on record. And so based on those, the monsoon, and along with the other precipitation and temperature patterns I'm showing, we can see that the Southwest, particularly Arizona and New Mexico, is one area that the drought has increased over the last couple of months. And also the Pacific Northwest, although that is changing. And so this on the left is the latest US Drought Monitor map from October 10th. And we see that, again, in Arizona and New Mexico, we have areas of extreme, and there are a few areas of D4, that exceptional drought in southern New Mexico, and some of the D3 extreme drought in parts of the Pacific Northwest. It is nice to see the white shading in pretty much all of California, Nevada, Utah, and parts of the Northern Rockies. So there are a lot of areas that are drought free. And then on the right shows how that map has changed over the last 2 months. And again, I kind of just summarized this, but really that lack of monsoon really led to increased drought coverage in parts of the Southwest. A quick update on the wildfire season. Even though it is mid-October, there is still a very normal to have wildfires in parts of the western U.S. before the the bigger winter storms start to roll in. So on the left there is a map of the current active large wildfires. Those are fires that are greater than 1,000 acres, and this is a map from October 13th. And still overall, it was a relatively quiet wildfire season across most of the West. There was some increased activity in parts of the Pacific Northwest. California had a relatively quiet season with the exception of that northwest corner of the state where there is a complex of fires still burning, and there are still some fires burning across the Southwest. But one thing I wanted to highlight was on the right is the outlook, which was issued at the beginning of October for below normal significant wildland fire potential for Southern California and coastal California. And so we're heading into the peak Santa Ana wind season for Southern California, which are downsloping warm winds that can often fuel and fan some of the largest wildfires in California's history occur in October and November. And so it's really good to see this below normal large wildfire potential. The rest of the West is normal, meaning, and that doesn't mean fires aren't expected, but just normal fire activity is expected depending on climatology. And these next two graphics show the outlook for November and December for significant wildland fires. And the entire map is white with the exception of Hawaii. But for places like, again, Southern California, where the season can extend into November and December, it's good to see that there isn't red shading and chances for above normal wildfire potential there. And so a good part of the reason why we have had this lower wildfire potential in the Sierra Nevada and Southern California is related to one, the water year maps that I showed with a wet winter, a lot of precipitation throughout the winter and spring. But we also had some fairly unusual storms in August, with the remnants of Hurricane Hilary, and then a Labor Day storm in early September, which brought some good anomalous rains for that time of year to the region. And so the fuel moistures have been relatively high. These two graphs, the top left is showing the 100-hour fuel moisture for the eastern Sierra Nevada region, and then the bottom right is showing the south coast of California region. And the blue line is this year, the gray is the average, and the red is the minimum on record. And so we see most of the year the blue line has been above the gray values, indicating higher than normal fuel moistures, making it harder for fires to ignite. There has been some drying over the last week or so, values falling slightly below average, but still nothing too alarming in terms of fire danger for the region. And I mentioned the soil moisture. This has been one of the key factors to reducing fire danger in the region. This map is showing the most recent 9-kilometer estimated soil moisture anomaly for the whole United States. But if we focus on the West, a lot of the area, with the exception of parts of the Southwest, is in those bluish colors, which are above normal soil moisture. And in particular, Nevada, Southern California, the Southern Sierra Nevada, into the Great Basin has much higher moisture in the soil than is typical for this time of year. And so this is great for reduced fire danger. This will also really be good to help runoff and water supply, thinking ahead into the spring of next year. If the soils can stay moist before we get the big snowfalls in the mountains that hopefully come this year, this will likely increase the runoff efficiency, meaning that more of the water that melts after the snowpack falls can go into running off into the streams and reservoirs and not having to saturate that soil. So the high soil moisture is good for many reasons across the West right now. And so I wanted to move on to the ENSO update. And so this information here is from the latest update from the Climate Prediction Center, which was issued this past Monday, the 16th of October. So we are currently in an El Nino advisory, and El Nino conditions are being observed. And I've highlighted on the map there the general ENSO region. And so sea surface temperatures are above normal in that region, and the anomalies are greater as you move further east towards South America. So the eastern ENSO region has higher anomalies right now. And the atmosphere is responding and is being consistent with El Nino conditions. And this event is anticipated to strengthen and continue through the Northern Hemisphere spring. There's about an 80% chance that that will continue through March through May 2024. So I wanted to show what those outlooks looked like. These are the Nino 3.4 index forecasts. On the top left are the probabilities of El Nino, La Nina, or neutral conditions for each season going out into next summer. And we can see the first 5 seasons are nearly 100% likelihood or chance of staying in El Nino through the next several seasons, and that starts to decrease as we go into next summer. And then on the right are the individual model predictions that make up the ensemble forecast, and you can see all of them do continue to show in El Nino. Most of them show it continuing to strengthen for the next few months. There is, of course, some variability, but the averages come out to show a moderate, potentially strong El Nino event by the time it's all said and done. And the last thing I wanted to highlight here was some updates to a tool that we have here at the Western Regional Climate Center that uses precipitation data and ENSO index data to give a sense on the relationships between precipitation and ENSO signal, not just for the Western US, but now across the whole US. And so the link for this is down on the bottom. And this is a tool that has been available for a while on the WRCC website, but it's been recently updated. And so previously it just had a handful of regions across the Western US to choose from. Now we have any of the National Center for Environmental Information, the climate divisions, across the entire United States. You can pick your climate division that you want to look at. And the previous version only used the Southern Oscillation Index, which is one measure of El Nino and La Nina. But we've also now added the option to pick the Nino 3.4 anomaly, which is an index that I think is used quite a bit more frequently now than the Southern Oscillation Index. And there's also potential to add more indices, as there are several more out there. So what this allows you to do is pick your index, pick your state, pick your climate division, and then generate these scatter plots. And so right now, the only option available is this June through November SOI or Nino 3.4, compared against the cool season, October through March precipitation totals. And so this is based, Kelly Redmond, who used to be at the Western Regional Climate Center, developed this based on a paper that he published showing that the strongest relationships between that cool season precipitation along the West Coast and ENSO was this sort of summer, autumn ENSO indice. And so I'm in the process of adding some more options there, and those should be available later this year. But I wanted to dig into these a little bit. There's a lot of information you can get out of these. So again, on the horizontal axis, you have on this example, the Southern Oscillation Index, with the negative values being El Nino, the higher positive values being La Nina, and then the green dots in the middle being neutral conditions. And then the vertical is the October through March total precipitation. And this particular graphic is for the California South Coast drainage, so basically the South Coast of California area. And so we have some statistics on the top right that show the correlation being negative 0.9 and the R squared of 0.15. So there is a relationship there. It's not incredibly strong, but we do see some things that stand out. If we look at the mean of the El Ninos compared to the mean of the La Ninas, there is quite a bit of separation there, indicating that on average, the El Ninos bring more precipitation than the La Ninas. But I wanted to highlight a few examples. So I've highlighted on the left there, the top two dots on the left are the 1998 and 1983 El Nino, which were two of the wettest years on record for this area. And those were strong El Nino events. But then we also had 2016, which was a very strong El Nino event as well, but brought just slightly below average precipitation. So there is a lot of variability there. And then also I wanted to highlight 2023, this past year was a moderate strength La Nina and was also one of the wettest on record. So you can download these images. You can also download the data files if you wanted to dig into the individual years like this to gain more information on these relationships. Now I'm showing the Arizona, Southeast Arizona Climate Division. And I just wanted to show you the difference between the Southern Oscillation Index and the Nino 3.4 anomaly. And so, although they're different indices, they both represent El Nino and La Nina states. And so they show similar patterns, they just have opposite trends or correlations due to that the El Ninos are negative values in SOI and they're positive values for Nino 3.4. And so this is another area that has a fairly decent relationship with El Nino events typically being wetter and La Nina events typically being drier. And lastly, I wanted to make emphasize here that so on the left here we have the Utah Northern Mountains Climate Division, and then on the right is the Washington Cascade Mountains Western Climate Division on the west slope of the Cascades. So in general, in the West, we have much weaker relationships between ENSO and winter precipitation in the middle latitudes of the Western US. So think central Nevada through the Great Basin, Utah, a lot of Colorado, where there's almost no relationship at all between ENSO and precipitation. And then in the northern, far north and far southern latitudes, there are stronger relationships, but these are by no means robust relationships, and it's not a slam dunk that if you have a strong El Nino, it's going to be wet or dry. And so there's a lot more going on that drives the precipitation patterns across the West. Oh, and I guess I had one final slide here, kind of building on that, showing the Climate Prediction Center's November through January outlook. And so this is starting to resemble a somewhat typical El Nino pattern, where with the precipitation, there are higher odds of below normal precipitation across the Pacific Northwest and Northern Rockies, and not a very strong signal across the Southwest, with the exception of parts of Arizona and New Mexico, where the odds are slightly tilted towards above normal precipitation. So we'll have to see how this event evolves as we move into the winter. And with that, I will end. So thank you very much. And I guess we can peek in the questions box as I pass over to Jan. Change presenters here. Who will give us start our oceanic updates.
Well, thank you, Dan. Can you hear me and see the slides?
Let's see, I hear you and see you. I'm not seeing the slides yet.
It says I'm sharing.
Let's see.
Let's see.
I see. Okay. It sounds like others can see them. I might be looking at the wrong window. So it sounds like
okay.
you're good to go.
All right. Cool. Great. Okay. So well, first of all, Dan, you always give the most fascinating talks, and I really love that tool. I'm going to use that with my class. So I'm the first of three ocean-based people that you'll hear from. I'm speaking on behalf of NANUS in the Pacific Northwest. I'm speaking on behalf of many. Okay, so if you've been a repeat participant in the West Watch series, you know that we've been talking about anomalies relative to climatologies, and we even had a great webinar last time that was focused on you know, how do we describe marine heat waves, shifting baselines versus fixed baselines. And NANES has decided that we're going to produce maps of both. As you can see, they're not all that different at this point in time, but as time goes on, they probably will be. For the purposes of this presentation, I'm only going to show you the fixed. So here we have July 20 of 23, excuse me, showing the El Nino warm positive temperature anomaly at the equator that Dan just talked to us about, but also this pool of warmish water, warmer than normal in the Northeast Pacific. And if I click through time, we see that those patterns don't really change. Here's the September. These are monthly averages, so I don't have the monthly average for October yet. But you can see that that warmer water is still there, though it's a little bit less in September. Okay, so warmer than average, but are they marine heat waves? And so a group that you see here is publishing this tracker according to the algorithm that Alistair Hobday published in terms of the magnitude and the perseverance of the duration and the severity of the temperatures, the warmer than normal temperatures. And so you see the different colors there with sort of that gold being moderate and orange being strong. And most of the marine heat wave is well to the south of the Pacific Northwest, and it's pretty offshore. However, there is that little patch off of Washington State that is moderate. Okay, so fortunately, we don't have to rely just on satellites. We can query the buoys, though that's becoming a little harder. So here is a buoy that I often show by the National Data Buoy Center of NOAA. It's called Washington, and unfortunately, it is adrift as of late August, and the data release stopped. I'll talk to you about Oregon, but its temperature stopped even longer ago. So I can't tell you what things are approximately 200 kilometers offshore, but I can say that in August, we saw some things in temperatures in excess of 2 standard deviations above the mean, with the mean being that black line, the pink, one at plus or minus 1 standard deviation on each side, and red +2. And so that's about a couple of degrees Celsius, or if you're a Fahrenheit fan, around 4. All right, so here we go now to the closer to shore buoys up and down the coast throughout the Northwest, and you see various NDBC buoys. But let's look at that black line and the dark blue line relative to it. It looks like in the north with Cape Elizabeth, you know, there might be a hint of what that marine heat wave suggestion is. It looks like it's been persisting a lot of time above the 1 standard deviation, though some dips. And as you go farther south, it spends more time kind of crossing the normal line and a bit more variable. So for the coastal offshore conditions, it doesn't look like anything's too severe in terms of marine heat. Will that change is the big question. Okay, so now coming into Puget Sound, a large inland sea in the state of Washington, we have some profiling buoys at where you see those red circles. The 2 on the left are in Hood Canal. The 2 on the right are in the main basin of Puget Sound and South Sound. You can see the buoys go to different depths, and we have different levels of stratification. The Hood Canal ones in that long, narrow fjord tend to get stratified, whereas these ones that are in the main stem are very well mixed. And anyways, what's our story here with temperature? You can see there's a lot of blue on this graph earlier in the year, and we've got a lot of missing data, which is a frustration. But if you look at Carr Inlet and look at those pink anomalies, meaning warmer than average waters that are starting end of August into September and currently, that may be indicative of the warmer than average waters. And if you look up one, even though the record's incomplete, Point Wells shows pink about the same time. Now in Hood Canal, the the oceanic water moves very slowly into the canal and comes in at depth. And so you can see this wedge of pink there at Hoodsport. So that's the oceanic signal. And so anyways, I think we are going to see some warmer temperatures in Puget Sound, but it's, you know, below 1 Celsius at this point in time. Here's salinity. And I was keeping track of how many times Dan said, and drought in the Pacific Northwest, and looks like projection for lower rainfall in the Pacific Northwest. And we have been having positive salinity anomalies now for quite some time. And I believe it is due to the hydrological cycle. And so that didn't change with this new update. And here's oxygen, and it's frankly, it's a mess. And I don't have time because there's a lot of really cool stuff I want to talk about. But you can agree that if you look at Toano and Carr Inlet, they're different. And that's why we have buoys in different places, because resource managers from tribes and states need to understand the risk of hypoxia, and that's not consistent. Okay, here is the remote sensing ocean color for the whole coastline. You can see that there's a lot of anomalies that are less than average, and you can see some little pockets of green, particularly in July and August, not so much right now. Again, these are monthly averages compared to that climatological mean, caveat emptor. But what's really exciting is this project that has been measuring domoic acid, the toxin that's in a diatom, Pseudonychia, that is can cause amnesic shellfish poisoning. So this is of high concern. We've had, and Clarissa can talk all about this, but it's exciting, this capability off the coast of Washington, and reported in near real time, the toxin. And so here you see the record from June to September, and you see those hits, and that's helping the investigators, John Mickett from UW, Stephanie Moore from NOAA, Northwest Fisheries Science Center, and many, many others, partners, including tribes, including state agencies, to focus on the dynamics and get a little bit of a warning. This feeds into our Pacific Northwest HAB bulletin, which incorporates this data stream as well as many others. So it's really great to see this technology, which if somebody had told me 20 years ago, I'm going to be saying this, it's just mind-boggling. So very exciting to see this development. I want to shift now to talk about waves. And Roxanne Carini, when she gave the talk a while ago, she focused on waves a bit more. And there's an interesting story to tell this month. So let's go back and look at those NDBC buoys that are about 200 kilometers offshore. Unfortunately, as I told you, the Washington one went kaputski the end of August. And this is what the NDBC website says: buoy adrift as of the end of September, and water temperature has been missing since May. But what's interesting is it's still recording wave height, and they're still tracking its location. So what you do see is this big spike here in the end of September, buoy adrift in September 24th. Remember that date. So now what I want to do is, and so we're mixing our units here. This is in metric system, this is in feet, and there's a reason why it's in feet. But so the maximum here was about 15 feet. Okay, so now these closer to shore, about 3 kilometers offshore, and we see a really high peak up here at Cape Elizabeth, and with waves over 20 feet. You see the spike in some of the other data too, but it's very prominent to the north. And what I want to share with you is this, because I was actually at sea on the Thompson helping with deploying buoys and working with students. And there was this bomb cyclone that was written about in the Washington Post, and had incredibly strong winds, but it didn't really make landfall so much, so you might not have heard about it. But I'm also involved in a project called Backyard Buoys, and I want to say that we have deployed these low-cost SOFAR buoys with the Quileute tribe. And this is the data record from theirs, and you can see around 20-foot wave height. And we just deployed one with the Quinault Indian Nation. And this is about 3 kilometers offshore. It's where they're going to be operating. So having these hyper-local buoys is really of value. And I'm sorry I've gone long here, but to summarize, we've got El Nino persisting right now offshore. It's not so warmer than normal, a couple degrees. In Puget Sound, starting to show that evidence, a little bit less. Really exciting to see the advances in both the high tech for the ESP, measuring domoic acid, as well as the lower tech and more human scaled addition of these wave buoys near shore. Okay, thank you, and sorry for going long. So.
No problem. Thank you for the great update as usual, Jan. They're going to move down the coast to Henry, and I need to pass sharing to him. Let's see. Alrighty. And you should be able to take it away, Henry.
Coming through.
It looks good on my end.
Okay. Yeah, thanks for the opportunity to tell you what's going on in the central Northern California area. And so something that has been happening on our coast quite a lot over the past few years is gray whales washing up on the shoreline, unfortunately, with mortality and so on. We just had an instance a couple of weeks ago, and you'll see on the top right there some information that's been put together by NOAA Fisheries on the unusual mortality event, as it's been called now for 4 years. And you can see it's already over 40 for this year, and is likely to get a little bit higher. And so the reasons for this have been discussed in many fora, and so some of you probably get asked by your friends and family about what's happening with this kind of thing as it makes the news. And we've been talking about things like the kind of compression of habitat with various climate conditions, and seasonal conditions, and then also that compression can lead to perhaps more entanglement with fishing gear. There can be harmful algal blooms and vessel strikes and things, all of which can contribute to this. But just this month, there was an article in Science that shows some pretty strong statistical evidence over a long time series about how these population dynamics and mortality events are linked to things happening far away from our region, at least in the Arctic, where their feeding grounds are impacted by ice and variations in prey biomass. And so this is it's just out, and so the debates will continue, of course, about what's causing mortalities like this. But this is a nice new bit of context for that discussion. And so, along with Jan, we have with Nanus, we have these ways of tracking wave information over time. Here we have on the top right, you can see a time series of some wave stations along our coast, informed by the Coastal Data Information Program for the last 10 days. And you can see that there were some fairly large swells moving through the north about a week ago. And in the center of your screen, you can see some wave spectra where the wave heights, for example, at Cape Mendocino, were getting over 20 feet in some cases in the past 30 days. And on the bottom right, you have some text. So frequently in our region, we have beach hazard statements talking about sneaker waves. And so basically, these can be waves that can be sort of rare in their occurrence. So you can stand at the beach for some 10+ minutes and not see anything particularly alarming, but then people can get swept out or injured, and tragically sometimes not be found with these waves. And we have one occurring right now over the next days in the region, and it's always important to remember these threats. And on the right side, you can see the broader wave forecast from the model that the CDIP program provides, where although there are the sneaker waves happening, the overall wave heights are not as much as we might see with storms and so on. So yeah, again, this marine heat wave topic is coming up. And so really enjoyed the discussions over the last few Westwatch meetings and following the topic. And we're looking to evolve how we create and share these products along with some of the other experts, such as Andrew Leasing, who's I think on the line today, and generates this so-called blob tracker on the right side, and there's a link to it there. And you can see from the last time that we've looked at this, there is, I think, fair to say, a bit of a reduction in the overall heat, and as Jan was showing, that a lot of the warmer water is to the south, at least from the northwest and central Northern California regions, although there is a little bit along the coast. And so on the right side, we have a product that's it uses the same classification construct that we heard about in the last talk with the Hobday et al. Marine heatwave index. And so this is running now from late September through present and just a few days into the future. And the way we do this is by using the WCOF's West Coast Operational Forecast System model instead of satellite data to produce the temperature estimate. You can see it just now going into the, well, what was now yesterday. So the overall, though, you can see some warming about a couple of weeks ago. It has since dissipated, and so things are pretty nominal at the moment for central Northern California. So the according to that tool, and so similar to what Jen presented for NANUS, I'll step through a couple of shore stations. So these are observations occurring basically at the shore, as well as some offshore readings in a moment. But the time series that you see there is 180 days, the last 180 days. And so we can see, as was discussed in August, there was some considerable warming at Bodega Bay and the Moss Landing Marine Lab in the Monterey Bay. We didn't have a station running, unfortunately, at the Trinidad Pier at the time, but we can see now some continuing more warm elements there, perhaps dissipated a bit from the August into September sort of intensity. And we have here also Point Arena offshore now, so some tens of kilometers offshore from the NDBC buoys, and notably the Monterey NDBC buoys now, I believe, temporarily being replaced by a sail drone, and so that the sort of data stream on generating figures is not quite plumbed through there yet, but we can see that the temperatures are almost 17 degrees at that station, and then some continued warming is similar to the other stations, albeit perhaps diminishing a bit. And on the left side of both of these, you will have seen the West Coast Operational Forecast System temperature, which ranges across about 13 degrees to just over 20 degrees across the whole viewed area there. So gliders, so we're operating several gliders in the region. This is a glider dashboard for a glider running off of Trinidad Head. And this is some older data, meaning it's this profile here that you see on the right side is from about, as you go from left to right, it goes from about July 24th into about the first week of August. And so this was occurring basically as the heat wave that we experienced earlier in the year, or earlier, late summer, I guess, was developing. And you can see there the temperature was about 20 degrees according to the glider observations offshore there, the surface. Here's another glider visualization. So this is for the Monterey glider line. So we're currently looking to harmonize how all these glider observations are provided across our glider operators. But going from left to right, you have got August, September, and October. At the top row is temperature, and the bottom row is the anomaly according to the 2007 to 2013 reference period. And with these, it's always good to take a quick squint at the scale bar so that the overall scale range increases as you go, or can vary, but in terms of temperature increases. although the actual peak temperature in the glider data is about 21 degrees, I believe. And so you'll see also that the temperature anomaly, according to the figure there, is pretty strong, and there are some geostrophic currents that are on the upper end of the variability over the year, meaning there's about half a meter a second occurring in relation to those temperature anomalies and other ocean physics anomalies, so that there are some interesting things happening, but nothing unusual that you wouldn't see at least at some point during the year. And then, of course, in the September period, almost the entire glider profile, horizontally, which is about 400 kilometers offshore, and vertically is in the warm anomaly. So upwelling, so the upwelling index is generated by Mike Jaycox and all. Many of you will be familiar with this, and this is an indication of both the upwelling along the coast, which can occur through wind-driven circulation. Its delivery of water from deeper down can have a cooler water and more nutrients often associated with it, and that's what's quantified on it. So in the center, you'll see two panels vertically. One is the coastal upwelling transport index, showing about the last 3 months, and below it, you'll see a longer term, 3 years or so of that index over time. And on the right side, you'll see the biologically effective upwelling, which is basically a metric for how much nutrients for phytoplankton production, similar to what Jan was quantifying in her talk. But in this case here, the nutrients that drive production are visualized. One of the things that's notable on this one is some downwelling in the coastal upwelling transport index just in the past about week or so, but has since dissipated. So the multivariate ocean climate index, and so this is, as it's described, an index that includes several inputs of variation. So it includes sea level stations, NDVC buoys, upwelling indicators, and climate, and a combination of climate indicators. And so I was able to get an update this morning that does not include yet the latest sea level information, but this provisional Northern California index shows an sort of upwards positive increase in the index, which can be related to El Nino. And in fact, in this case, it is the forcing functions on the various inputs of this are suggesting that the Northern Oscillation Index is one of the primary drivers of what we're seeing here, which the Northern Oscillation Index is a El Nino indicator that covers both the northern and southern hemisphere and its variations, and so is really great for the region. And here's Central California. Looks almost identical, with again a modest uptick, but not into significantly unusual conditions that might be associated with an El Nino. And lastly, just a quick touch back to headlines. And so I think most folks will be familiar with the Integrated Ocean Observing System of the United States receiving some new funds for delivering coastal climate information. And so one of the exciting topics that we'll be looking to cover in that is how we can create products and services like what you're seeing here in a way that's beneficial to more people and more readily interpreted in such things. We'll also be doing some, in our region, some new work on harmful algal blooms that's supported by the National Centers for Coastal Ocean Science and IUCE. So working on harmful algal bloom imaging systems. And then just one last item is the Coastal and Ocean Modeling Testbed has a call that's now open for proposals. And some of the things that you've seen today from us and others includes, has benefited from this COMT testbed, as it's called. And so I'll stop there.
Thanks, Henry, for that update. We're gonna continue down the coast to Clarissa, and then if we have some time at the end, we will take questions, but I wanna make sure we have time for all our presenters.
Thanks. I will rush, as I feel like I often do, to get through the HAB story and give Jim some time to talk about CDIP data. hopefully we'll have time for questions. So I wish we didn't have HABs to talk about all the time, but I am going to focus on that. I'm going to first turn this over to Jim. Let me get this in slideshow mode. Can't see anything. Here we go. Slideshow. Okay, so that was my intro, and I'm turning this to Jim.
Hello, folks. I think I'm unmuted and on video, hopefully.
Yes.
Great. Greetings from Scripps Oceanography, the home of Coastal Data Information Program. We have some new stations on the West Coast that are now active. One of them is in Tillamook, Oregon. The Army Corps has funded that one. Pajaro Beach now has 2 stations nearby as part of a wave dynamics study that's funded with California State Parks as well as the Army Corps. And with Marine Corps near Camp Pendleton, we have 2 new stations that are active, a near shore and an offshore. The Green Beach station was smashed recently, as you can see, not too long after we put it out there. This is always a risk for us. And one of the things that we're working on is visibility of the buoys and keeping the data flowing in that regard. That Pajaro Beach photo on the right shows that we've got little marker spars, and that yellow ball on the antenna has a radar reflector in it. We've been doing what we can to protect our sensors. And then the Umpqua and the Angeles Point stations have been down, but are both pending redeployment in the next hours to day. And then Point Santa Cruz was recently decommissioned as part of it was just a temporary station, in case somebody's missing that. And the Cabrillo Point station at the south end of Monterey Bay has been sponsored by Hopkins Marine Lab for many years, but we're trying to find a steady supply of funds for the future there. In case anybody has any ideas or has a particular use case for that buoy, we'd love to hear about it. That's CDIP 158 Cabrillo Point. Next slide, please. West Coast wave activity, we've heard a little bit about this, so I won't go too far into it, but we've got these nice climatology plots on our website for each station as well. Just looking over there on the lower left, CDIP 179 Astoria Canyon, which gets exposed to generally the biggest waves that we see on the West Coast in our array by virtue of its location there and its depth. Picked up, as Jen mentioned, the early bomb cyclone storm in late September, and we're heading into the typical winter wave activity season. The temperatures have been kind of all over the place this year, as you can see with a sample plot from way down south in Imperial Beach and way up north in Grays Harbor. One more slide. Please, the next slide. This is kind of a nifty little image of super typhoon. I'm not sure how to pronounce that. Bolavin. Pardon me if anybody know how to pronounce that, and I've offended you in any way. A long period swell generated by this Category 5 storm. We first measured the waves. You can see on the left over there, we were developing a SYN tool environment. This is synthesizes the various wave models we're ingesting with the observations. We have some drifters and some moored stations out there by Guam and Saipan is what we're looking at. So this was the early stages of that storm. It proceeded across the Pacific, and what I'm showing on the right is the peak period forecast for 12 UTC tomorrow, based on the ECMWF models that we've been looking at lately. That's 20 plus 25, reaching 20, approaching 25-second peak period. You can see the shadow from Hawaii. And so this is early activity in the El Nino phase, where we're going to see these swells that have exceptionally long periods in the earliest arrivals and a lot of power as a result. That's over on the right, we're showing the Astoria Canyon, both the data in blue and the forecast in red, and you can see that the peak period is forecast to shift into 20 up to near 25 seconds. So thanks for your attention. Thanks for your time. Off to Clarissa.
Thanks, Jim. I think I only have 4 minutes, so it's going to be really hard to do justice to the slides that I have on this harmful algal bloom. I don't want to barrage you, but I don't see how to get around it. This event was huge. You all know we've reported on it in the past. I want to give you a summary here of where we're at with the tally of animals that stranded or were deceased. Many of these were euthanized, was mostly California sea lions, a lot of Long Beach common dolphins, and that was what made some of this interesting, as well as the fact that there were attacks on humans due to erratic behavior, and that was well covered by NOAA and various press releases. I wanted to show you the data from our HabMap shore stations. I'm going to run through an animation that's going to probably make you woozy because I'm hurrying. I want to point out that we have different size classes of this diatom, some that are toxic, some that aren't. It really was, if you march through this time period of the bloom, it really was the less toxigenic size class that bloomed. If we had really been monitoring this on a high frequency basis, we still probably would not have alerted anybody to this just from a nearshore perspective. But a month later, we did get domoic acid results. We do see high results only at San Luis Obispo Pier. Much later into the bloom, we start to see some blips at Stearns Wharf. The hub of this was at Santa Barbara Channel, so that's very interesting. And we only see a shellfish advisory much later in the season in Santa Barbara County. And in fact, we only now are seeing the spiny lobster season delay that's just opening today, only in Los Angeles and Orange County, which is not where the preponderance of animals stranded or where we saw a lot of domoic acid. So this gives you a sense of the horizontal and vertical variability. The vertical variability I'm not showing you, but this is how we sort of have to deal with this kind of heterogeneity that makes this so hard to be predictive and understand what's happening with animals. I'm going to talk about ENSO. We heard a great spiel from Dan about the weak correlations with precipitation. There's long-standing, long-held beliefs that these HABs, and especially the impacts on marine mammals, are tightly correlated to El Nino. I want to walk you through some evidence of that in a minute, but here's the glider data showing how on track Southern California actually is this year with what's happening at the equator, at least in terms of temperatures starting to rise in a very synchronized way with the way that they are rising in the equatorial Pacific. But this does not necessarily indicate that we would see the water column or water physics changes that you would then associate with the kind of nutrient regime shift that you would then think could lead or drive a bloom of this sort. Andrew Lysing gave me this slide that he presented in the last webinar. If we just take a time series like this, where we're looking at many of the ENSO events and marine heat waves over the last 20 years, at least the very large ones, and we step through it, I'm going to point out that at least from a perspective of impacts and domoic acid events overlaid here, we don't see a great correlation. We often see a DA event in the early part of the El Nino, or we see it in the spring after, or we don't see one at all, or we then see it in the spring after. We have a marine heat wave associated with a massive domoic acid event, and then we have a Godzilla El Nino associated with nothing the following year. We have marine heat waves that precede some things, and then we have domoic acid events that precede the marine heat wave if you actually look in space and time at when these things are happening. And then we have June 2023, where a D event started, but too soon for us to really see the manifestation of El Nino at our latitudes. If we do the same thing with marine mammals, I just want to point out that there's a pretty dramatic step change at the year 2000, but we weren't really monitoring marine mammal strandings very well prior to that. They were associated with a couple of El Ninos. There was an El Nino that didn't have much of an association. If we look at post-2000 and we march through, I'm not even going to step you through this, we just don't have time, but the point here is that the peak stranding events often happen in June when we see some behavioral changes in animals that lead to that. Some of the weakest El Ninos have the highest peaks, but they're not at the time of year when you might expect them. They're certainly not always in the spring following the beginning of an El Nino, which is when we would expect to see the water column changes that would lead to domoic acid production. So just from this year's perspective, you've seen some stuff about upwelling from Henry and others. If we look at Cutie and Beauty, for instance, I think there's something to be said there. Our shore stations show that we've seen pulses of upwelling last August with one of the HAB events, and we saw anomalously cold water this year associated with this HAB event. And if you look at Beauty in particular, while Cutie was anomalous this year and last year, nitrate availability via Beauty was anomalously average or even potentially low, which could suggest some sort of nutrient depleted environment in that upwelled water that would very well explain domoic acid production. We've explained all of this in a Harmful Algae News article. I hope you guys can look this up. This is a UNESCO publication, and I'll just leave it there and you can read our summary elsewhere. And thank you for your attention.
All right, well, thank you so much for that, Clarissa and Jim. I'm sorry we had to rush through that at the end. The Art 301, there are a number of people still on the line. I don't see any questions. I see one question from Mike Anderson that I will try to quickly address here. That was for me, related to any thoughts on how the marine heat anomaly between Hawaii and the mainland US might be impacting high pressure systems in California right now. And I typed in the chat box that I don't really have a good sense of how that's going to impact our weather here along the West Coast. Other than the recent return to colder low pressure systems off the coast of Oregon and Washington have dampened the marine heat anomaly off the coast there. And so I don't know how the interplay is going to act there. We would think that the warmer waters to the south might promote ridging, but then it's cooling a bit to the north. And so this is kind of a chicken and egg situation. And I don't know if there's a consensus of how the interplay goes between those systems. So we are at 3:02. I don't want to keep people any longer. So thank you so much for joining this month, and hope to see everyone next month for the next West Watch. Thank you. Have a good afternoon.